goal of this video is to talk about the remainder theorem and how we can apply that to help us with some problems down the road. So here's what the remainder theorem states. It says that if you have some polynomial p of x, which that can be any polynomial, in this particular case, the example that we're going to do, the polynomial p of x is x squared minus 3x plus 7. This applies to any polynomial. And if we divide that by a linear expression, and what we mean by linear expressions is can't have any exponent bigger than 1, so we couldn't have like an x squared or an x to the third. It's got to be x to the first power. Linear expression, which they're calling x minus a, then the remainder of that division problem will be p of a. And so here's what that means in plain words. If we do this division problem, which we're going to actually do the synthetic division and find out what comes out, what we're claiming is if we plug a, whatever value is being subtracted from x, that's what we called a, if we plug that value into the function, what comes out will be the remainder. So let's do the actual division, okay, and see what happens. So what we're going to do is a synthetic division problem. So I'm going to set up my synthetic division symbol. Okay, my a value, you have to be careful. This has a minus sign in it, so my a value in this case is 1. If you see a plus sign here, you're going to have to switch the sign. If this was like x plus 5, we'd say a is negative 5. So whatever value is there. Right, so we're going to actually put a 1 here. Just similar to what we did when we were doing synthetic division, we always use the opposite sign. Okay, so I'm going to plug in the coefficients for this polynomial, which is 1, negative 3, and 7. Okay, and we are going to do our synthetic division. So we started by bringing down the 1 and multiplying. 1 times 1 is 1. Add together these two expressions. Negative 3 plus 1 is negative 2. Okay, let's do another multiplication. 1 times negative 2 is negative 2. I'm going to add down the column again, and I'm going to get a 5. Right? So this is my expression. Okay, we have one term out here, so I'm going to cut it off at that last term, and we're going to write our expression. The answer to this division problem is the minus 2, and remember this is x to the first, and if we keep going, we'd say coefficient x to the first, x to the second, x to the third, etc. So we're going to say in this case x, 1x, minus 2 is my quotient, and then I have a remainder of 5 over x minus 1. And so we'd say this is the answer to the division problem. So if I ask you what the remainder is, the remainder in this case is the 5. So what the remainder theorem is saying is if I just took the 1 that was a, the same one that we used over here, and I plug it into this expression, let's find out what happens. It would become 1 squared minus 3 times 1 plus 7. Well, 1 squared is 1. Negative 3 times 1 is negative 3 plus 7. Okay, well this has 1 minus 3. That's negative 2. Negative 2 plus 7. That is the exact same 5 that we got as the remainder. So if you're just curious about the remainder and you want to see if there will be a remainder, we can just plug in that value from the linear expression, and that will tell us what the remainder is going to be. And so you might be asking yourself, like, well, why would I care if something is a remainder? Here's a really big important idea. If the remainder is 0 when we plug in, that means that the value that we are dividing, the linear factor, is a factor of the expression. If we're trying to factor it and solve, which we're going to do later, we might want to check to see if this number, x minus 1, is a factor at all. Well, a quick way we can check that is just to plug the 1 in. If a 0 comes out, then yes, it is a factor. Okay, so we're going to use it for problems like that. So here's one more quick example. Okay, so we're going to use synthetic division and the remainder theorem to find p of a. Okay, so they're saying a value is equal to 3. So we're going to do it in both ways. This is very similar to the last one we did, just asked a little differently. So they're saying use the remainder theorem to find p of a. I think that's the easy one. We can just do p of 3. Okay, and we're just going to do 6 times 3 cubed minus 3 squared plus 4 times 3 plus 3. All right, well, 3 to the third is 27, and 27 times 6, let me bring up my calculator, 27 times 6 is 162. So we got 162 minus 9 plus 12 plus 3. All right, so if I put together all of these terms, okay, again, go back to the trusty calculator that you guys can't see, minus 9 plus 12, plus 12 plus 3, 168. Okay, so I'm going to say 168. When I plugged in a is equal to 3, I got a 168. So let's try the remainder theorem, or the synthetic division, and see what happens. If I use this as a 3, okay, and again, really what this means by using this a value of 3 is that we're dividing 6x cubed minus x squared plus 4x plus 3 by, this is what our problem looks like, minus x squared plus 4x plus 3. We're dividing it by x minus 3, right? This is a positive 3. That means I'm doing a subtraction in my problem. I'm looking to see what the quotient is of this problem, right? So we're going to bring down our numbers. I have a 6, a -1, a 4, a 3. I'm going to do a quick scan and make sure I didn't skip any coefficients, because remember, we do need zeros for those. That's 3, 2, 1, 0. We're good. Okay, so let's go through the problem. If I bring down my 6 and multiply, it looks like I get an 18, which I can add, and that gives me a 17. When I multiply 3 times 17, I get a 51. Okay, and then I can add again, and I get a 55. Okay, and then I'm going to do one more multiplication. 3 times 55, I believe, is 165. And if you notice, when I add down the column, there's the same 168 remainder that I got just by plugging in the a value.